Hello, today I'm going over atoms, ions, and molecules biology lecture. So this is just an intro. This would be a refresher if you maybe had this stuff in middle school. So we're just going over the very basics of this, and then you'll expand on these basics. So this first image here, we have a drawing of the structure of an atom. Now this is not to size or accurate in how we think it actually looks, but it gives us a good idea of what is happening with an atom. Everything around us, including living and non-living things, is made of tiny particles called atoms. So this whole thing is the atom. An atom is the smallest unit of matter and thus is extremely small. So we cannot see this with our eyes or with a normal microscope. Atoms are made up of three smaller particles: protons, neutrons, and electrons. So these are your subatomic particles: protons, neutrons, and then electrons. Down here I've got another image that looks similar to this one up at the top, but we've included a couple of other things. Protons and neutrons are in the center of the atom, forming the nucleus. So you see here, this whole area is labeled the nucleus. Electrons are much smaller and move around the nucleus. Electrons in these orbitals here in blue. Protons have a positive charge. Electrons have a negative charge. And neutrons have no charge. So when we talk about charges, we're talking about magnetic charges, right? Think of like a magnet that has a positive and negative end. Same idea. All right. So I've got some more diagrams here of atoms, but a couple of different ones. Looks like one is labeled as oxygen and one is labeled as hydrogen. But now we want to get into why is this one oxygen and that one hydrogen. An element is a type of atom that cannot be broken down into a simpler substance. Different elements have different numbers of protons, which make them unique. So when we say this can't be broken down, we're not talking about the subatomic particles, right? We're not talking about taking an electron out or a proton out. We just mean this is the basic unit. Anything smaller than that is subatomic, and not part of that basic unit of an atom that we talked about, or not something that's a building block. For example, all hydrogen atoms have 1 proton, while all oxygen atoms have 8 protons. So if I ever change this, if I take this oxygen atom and I remove a proton, well, it's no longer oxygen, because the number of protons tells me what element I have. If I take the hydrogen and I add a second proton, it's not hydrogen anymore, it's helium. Electrons move around the nucleus of an atom in energy levels, which hold different numbers of electrons. That's what we see here. We see 2 orbitals where the electrons are going around the outside. Again, this is just the very introductory ideas. We're going to find out later that the electrons don't actually make these nice circular paths around the nucleus. But it's good for our initial model. It gets the concept in our heads. The first energy level holds 2 electrons, while the second can hold 8. And then there's more beyond those 2. But you see this first orbital only has 1, 2, while that next one has 8 electrons. Atoms are most stable when their outer energy level is full. So whatever that outer orbital is, if it's full of electrons, the atom is happy. It's when it's not full that it starts to get reactive. These here are 6 different atoms, and the abbreviations let us know what they are. So carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Of the 91 elements on Earth, only 25 are found in living things. 4 elements, carbon, oxygen, nitrogen, and hydrogen, these ones here, make up most of the human body. Other important elements like calcium, phosphorus, and iron are needed in smaller amounts. So there's other elements that our body needs, but as far as the structure of our body at the cellular level, tissue level, it's mainly composed of these 4 elements: carbon, oxygen, nitrogen, hydrogen. Atoms can bond together to form compounds which contain 2 or more elements in a fixed ratio. So if you look at this image, I have 2 atoms here that are the same, and then a third atom here which is different from these ones. The properties of a compound are different from the properties of the elements that form it. For example, hydrogen and oxygen are gases, but together they form water. So this is a hydrogen atom. It's bonded, sharing electrons, to an oxygen atom. And in this particular case, we have 2 of those hydrogens bonded to this one oxygen. That's our water molecule, different than oxygen gas or hydrogen gas. Okay, I hope this introduction helped you. Let me know if there's any questions, and have a nice day.